Applications of percents. So with this lesson, we're going to take everything we've learned so far about ratios, rates, unit rates, proportions, and percents, and put it all together. Oh, and do some fun word problems. I know everyone loves those. All right, so let's start with this one. Sebastian ran 2K of his 10K race in 18 minutes. I'm going to erase that. At this rate, how long will it take him to cross the finish line? Okay, so we know that it took him 18 minutes to go 2 kilometers. So it would be good if we knew the unit rate. So the unit rate, anytime you want to find the unit rate, you just have to divide. Remember that this fraction bar means divide. So 18 divided by 2 will give us the unit rate. Another way to look at it is through a proportion. If I want the denominator to be 1, so in this case 1 kilometer, then I'd have to divide by 2. If I divide by 2 on the bottom, I have to divide by 2 on the top. So then it's another way to get 9. So my unit rate is 9 minutes per kilometer, or 9 minutes for each kilometer. Now, if he has to run 10 kilometers, and he knows that each kilometer takes him 9 minutes, then to figure out how long it's going to take him to run the entire race, we can just multiply. I'm going to do this multiplication with the units so you can see how the units will cancel out. So here's the length of the race is 10K. Then it's 9 minutes for each kilometer. So if I look at the units here, the units are going to cancel, right? Kilometers cancels with kilometers. And that's why my answer is just in minutes. So it will take 90 minutes for Sebastian to run this race, if he keeps his rate consistent. All right, how about this one? Sienna finished 1/5 of her homework in 2/7 of an hour. At this rate, how long will it take her to finish all of her homework? So it took her 2/7 of an hour to do 1/5 of the job, basically, right? I'm just going to put homework. So we want to know how long it will take to do one complete job, right? We're going to call her like finishing her homework. We're going to say that that would be completing one job, right, of homework. So again, anytime you want to find the unit rate, you have to divide, right? So 1/5 divided by itself will give us 1 on the bottom. So we have to also divide by 1/5 on top. Fraction division. So we've got 2/7 divided by 1/5. And by now we know to divide fractions, we do keep, change, flip. And the answer that we get is 10, right? 2 times 5 on top, 7 times 1 on the bottom. Now, you probably wouldn't say 10/7 hours. It doesn't really sound like it makes sense to say in a real world context. So you might take that 10/7 and you might convert it to a decimal by doing 10 divided by 7. Or I'm going to convert it to a mixed number. 7 goes into 10 once with 3 left over. All right. Now, if you wanted to convert it into hours and minutes, this would be 1 hour. And then to get the minutes part of your answer, you would take this fractional part and multiply it by 60 minutes to figure out how many minutes 3/7 of an hour would be. Okay, so lots of different ways you can leave the answer here. Mixed number, decimal, or even hours and minutes. All right, Trace thought he was going to spend $125 at Disney World last weekend, but good news, he only spent $78.75. What is Trace's percent of error? Let's talk about error first. Error is how much you were off, right? So I thought I was going to spend $120. I only spent $100. I was $20 off, right? That would be like the amount of error. So let's find that first. He thought he was going to spend $125, but he only spent $78.75. So let's figure out that error. If I do this by hand, I would have to add a decimal and 00 after, because when you add or subtract decimals, you have to line up the decimal points. But I'm going to use my calculator. So 125 minus 78.75 is 46.25. Well, he was off by a lot, right? But that's good. Maybe he ended up saving money on certain things that he thought he was going to have to pay a lot more for. Okay, so now we have to find the percent of error, because this is how much the error is, right? This is the amount of error. But we need to find the percent. In order to find a percent of anything, you're always going to do that part over the whole. The part here that we have is our amount of error. So we're going to do our error over the actual amount to find the percent of error. It's going to be error over actual. So error over actual would mean that we're doing 46.25 over the actual amount spent, which was 78.75. So we're going to divide 46.25 divided by 78.75. That is, and I'm going to use a squiggly equal sign here because that means approximately, means I'm rounding. I would get 0.587, let's say. Maybe even throw in that last, or the fourth value. So if I round this to a percent, that means that it's approximately 58.73%. So that is Trace's percent of error. All right, let's take a look at one more. Nadia thought that her language arts project would only take 40 minutes, but she worked on it for 52 minutes. She says that she spent, there's a typo here, she spent 130% more time than originally planned. Is she correct? So let's figure out what her percent of increase was here. So it's very similar to what we just did. We're going to find the amount of the change, right? This formula for percent of increase or decrease is going to be change over original, right? Change over original. So the amount of change here from 40 to 52, we would subtract those, right? 52 minus 40, I'll give you a minute, is 12. So our change is 12, and originally planned was 40. Right? Now we're going to convert this to a percent. So that means we're going to go through the decimal form first. So 12 divided by 40 is 0.3. Now we convert that to a percent, and that is, remember how to do that? Here's a little refresher in case you don't remember. 3/10 is 30 hundredths, which means this is 30%. right? Another way to do that, to convert from the decimal to the percent, is to move the decimal point 2 places to the right, right? Okay, so we have 30% more time that was spent. Not 130, but 30% more. Okay, so if it were 130% more, that means that we would have our original 40, right? Well, let me show you what 30% increase looks like. We have our original 40 plus our 30% increase, right? This is our original amount, right? And then we're adding on to it our 30% increase. Yeah? If it were 130%, we would start with our original amount, which is 40, right? That's our 100. Then we would add on another 40 and 30. Right? We are not oh, sorry, there's an extra 0 there. We are not increasing it by 52. We are only increasing this by 12. So it is only a 30% increase. She only spent 30% more time, not 130%. Okay? All right, that's it. Percents, word problems, proportions, bringing it all together.